Factor x to the 5 over 2 minus 2x squared minus 3x to the 3 over 2 plus 6x to the 1 half. Okay, so 4 terms wouldn't be so bad. The coefficients are all nice enough, but the powers in many cases are fractions, which is a bit of a mess. And we may not be able to make them all stop being fractions, but if we have to factor something out of this, the one thing that's for sure is that every one of these terms contains at least some x. In fact, every one of these terms contains at least x to the 1 half. Most of them have more. So the amount of x that we can pull out is x to the half power. It turns out that's the only common factor, so out it goes. And what happens after that is just a matter of subtracting fractions a lot. Here we have x to the 5 over 2 minus 1 over 2 has been factored out, leaves us with x to the 4 over 2 minus, the 2 hasn't been touched, we have x to the, how do we do this? 2 minus a half is 1 and a half, or what's better is, if you think of 2 as a fraction, it's 4 over 2. So 4 over 2 minus 1 over 2 leaves 3 over 2. With a little practice, you can do these pretty fast in your head. 3 over 2 minus 1 over 2 leaves 2 over 2, which I will clean up in the next line. Sorry, there's an x there. And then we get 6. X to the 1 half minus x to the 1 half is x to the 0. You could write x to the 0, but we typically don't. That means there are no x's left in that term, so the term is now just plain old 6. If we clean that up a little bit, we get x to the 1 half. X to the 4 over 2 is simply x squared, minus 2x to the 3 over 2. There's not much to be done with that. Minus 3x to the 1, which is plain old x. And then we have plus 6. I would probably stop there, although if you wanted, x to the 1 half is of course the same as root x. So if you wanted to do this and say x squared minus 2 root x cubed minus 3x plus 6, that's not so bad either.